it's the vehicle wear there and fuel.
Well, it gets into time, that's why I'm there.
Well, the thing is, you guys debate is it worth it. I mean, you're most likely going to start at $20 an hour. Because you're going to start at a T4 micron if you get recruited. And then again, depending on your location, you may be able to qualify for relocation assistance.
I was thinking about that. Well, did they let you guys know any kind of standards they're looking for out of the students? Would anything disqualify anybody? Or?
The big thing they're looking for, they want to see a 3.0 GPA and your attendance. Attendance is a big factor. He said, if I can't get you there, I'm not keeping you. It's just like the no call, no show. Your whole history of working at Micron, the first time you do a second no call, no show, you're done. Your second one, don't even go back, your history. That's the reason when with the guys that was, well, I even mentioned in the electricity class, you know, if you give me 3 no call, no shows during my semester, we got to have a talk. Because if you're going to do that for school, and that's only in a 3-month span, well, there at Micron, you wouldn't even got the opportunity for the third one. And it wouldn't matter if you'd been there, 2 months or 10 years. So, everybody's in tune with what I'm talking about, right? You understand? All right, we finished up getting back, we'll reel this back in for our fluid power. The other thing I'm going to mention, I went up to Fastenal, and Fastenal now wants to take and try to challenge the prices we have for the Mac tool setup and see what they can do, see if they can beat the prices. So I'm going to give them the opportunity to do so.
Come out on the bag?
Everything, the whole package. He says, well, I'm sure I can beat the price. I said, just understand it. They're doing 60% off.
He wants a business.
I said, that's fine. Because what he's going to do is he's going to go to all his tool suppliers and say, look, we're looking to work with a college that now they're getting about 12 every semester, or 12 or more students in this program, which as soon as more people find out, this thing's going to grow. This is going to be a college toolkit. What kind of brakes you would cut? Because now we're looking at quantity purchases and not just one here, one there.
Yeah.
And they're even looking to see what they can do for that multimeter. He deals with Milwaukee multimeters. He also sells Fluke, but his biggest one is Milwaukee. I didn't even know Milwaukee made multimeters. I didn't know it until Wednesday when I went up to buy Stacon connectors to do the wiring with. And they actually have, it looks just like, or really resembles that T5-1000 that I was showing you. But theirs is $190 versus $130. He says, well, let me see about the educational discount.
Yeah, it doesn't make long either.
I mean, they got some nice meters. I mean, he actually had a regular digital multimeter there, but then I told him about that feature that Mac has on theirs. The Mac man didn't even know they had that feature. Mac tools on their multimeters, for those that didn't look that close, the reason that it's so, I'll stand up and say this. On a multimeter, the reason there's such an issue with having a Cat 3 and Cat 4, Cat 3 1000, Cat 4 600 volt rating is to handle first the transient. However, when someone hooks the meter up wrong, like this right here, I just plugged it into the 10 amp current connections for checking amperage. If I turn the selector to voltage and go to check voltage, I'm creating a fireball. Well, Fluke does a better job because they have a much larger fuse, heavier duty circuitry to handle that, but it's still, you got to run the risk, depending on the surge that happens to go through it, it could possibly explode. All right. One of these are going to. They use that little glass fuse that might be a 1/2 inch or 5/8 of an inch long, and you seen what the arcs was jumping across. Well, you go from 1 1/4 to 1.5 inch fuse, it has to try to span that distance. Generally not going to happen. Where you've only got maybe 3/8 of an inch that it needs to jump. Quite possible. That now becomes a nice fireball in your hand. So, what Fluke or what Mac did, until you turn the selector to amperage, you can't plug it in over here for amperage. And you can't plug it into milliamps until you turn it to the milliamp selection. Because this guy for milliamp and up to 10 amp, you have to have it on the correct selection in order to plug it into the correct terminal. Period. So they kind of made it, I hate to use the word, but idiot-proof in that regard.
Now what if you already have it plugged in?
You can't turn the dial.
Oh, that's a nice feature. That's a very nice feature.
Because this is what gets people hurt or killed. So you had your meter set up to what you was used to. Say Ed come along and he asked you and you didn't remember him asking you. And he said, can I borrow your meter? He said, sure. And he goes over and he's checking amperage on a board and doing it through the meter. He rolls the leads all up nice and neat like you had them, but he doesn't remember to put the plug back over. You know what you're used to having, it at. You pull the leads loose, you turn it over on voltage because you never measure amperage with it. You got an amp probe right in your pouch. Never ever do you use for amperage. So you go to check your voltage, it's in your hand, you go like this and it blows up in your face.
They don't have like, you could just take the plugs out and put it into a neutral cavity, you know?
Nope. You either take the leads out, or you're going to have it in either voltage or amperage. This has a 10 amp max setting on this one. A lot of the Fluke will actually do a milliamp on one receptacle or one banana jack connection, and then 10 amp on the other banana jack. But again, I'll reemphasize this one thing. If you're going to skimp on some of your tools, you want to save some money. I don't, fault you for that. Don't skimp on this one.
What's a good one cost?
That one Fluke is $130. That T5 1000 that's actually being handed out to Ecolab employees, their maintenance staff. This is what you're going to use. Because with the T5 1000, you can't take the leads loose. They're only used to check continuity and voltage, period. Period. It has a fork in the top of it. You slide over the wire to check amperage. So the meter actually has a receiver up here that you turn on amperage, you slide up over and then you read it.
I bought one at Lowe's, Jason. I can't remember if it was a Cat 3 or a Cat 4. It was about $90. Yeah.
But remember what it told you to look for in the back, right? The UL, TUV, and CSA.
I bought that one for $20 and took it and showed it to him, and he said, "First thing,
I got one worse. You ought to see this one. It came with one of my trainers. I mean, well, I'll walk out here and get it real quick. But
That T5 1000 and you talking about how much is that go for?
114. We found it online, but it's retailed at 130 or 134.
And that's the one that Ecolab.
Ecolab that's the one that they tell their employees you're going to use, their maintenance staff.
Some of them Flukes, they were $200.
I never even unpackaged it. Pass it around. I mean, I wouldn't even take it out of the pack. Lab Bolt sent it to me, and I called. As soon as I took it out of the bag, I was on the phone. Dan Stearman was still here. He said, "What are you doing?" I said, "I'm not going to put that joke in anybody's hand." He says, "What do you mean?"
Because you listed.
Yeah, it is. For hurt. Well, it should say UL listed. Ouch.
But you said it's not going, don't the UL, they have to.
All right, UL listed, but look at the CAT rating.
Oh, it's only one.
Sir, yes, sir. How can I help you,
I
sir?
feel like a multimeter like that, it's basically only for like very.
Circuit boards.
small uses. Yeah, that's what. I
Don't
mean, I could
take it
see
out
us
of the
using
circuit
that
board.
in our digital electronics class in high school, but I don't know. Like, not all multimeters are designed to be in an industrial setting.
Key point, and that's the reason they do the CAT ratings. And it is UL listed. It is UL rated for that CAT rating. All right, but that's the thing. And if you paid attention to the Fluke video that we had, a CAT 1 was circuit board, control boards.
Yeah.
CAT 2, now we're getting into some residential wiring. CAT 3, now we're looking industrial. And obviously CAT 4, we're looking at substations, power, both overhead and underground power runs. But it's understanding your environment and understanding what's going on. Now, let's get back to our hydraulics. Now we've already went over flow control, we've done pressure control, all right? We've worked with volume, or the actual squared area that fluid's making contact to determine the amount of pressure that would be exerted by the shaft of the cylinder with a given pressure of fluid put upon it. So we went through all those different formulas. We've seen it in real life when we hooked everything up on the trainer itself.
Here, John. What page is that? What you have up? Is that where we're at?
122. We're now going into Unit 3. It says basic circuits, but it's also the one thing that you get into, and the first picture it shows you is actually a front end loader. And why would hydraulics be important there? And the term that it makes it important is called synchronization. Everybody knows what synchronizing should ring heavily with you working on cars. And I see Alberto shaking his head. Synchronization of cylinders.
Timing.
They have to operate in unison.
Right.
Have to operate in unison. The forces exerted on that front end loader with the two cylinders, if it was not working in unison, could literally tear it apart. Because if I got one that's lifting twice as much as the other side, or I should say one side lifting twice as much as the other side, I could really distort the front end framework when I got a heavy load on the front, right? All right, Jeff?
I guess so.
Yes.
I was thinking about it. I was trying to figure out how can you get them all.
Say that the other side failed. I blew a line on the other side. Or someone, they took the line
yeah,
off
yeah,
and capped it. And only this side was lifted. What's going to happen?
It's gonna.
It may not break it, and it may not be as visible to you sitting inside the cab as to what's really going on. But I bet you it won't be long, something's going to break.
And you probably start losing all your fluid too.
Well, but if say it broke a line and I capped it, which made the one side inoperable, but I was able to maintain the fluid until they was able to bring me another line in. I didn't have a line on the job site. I'm out. I'm part of the excavation crew. And Billy Bob says, wait a minute, I'll cap this off. I got some plugs with me. I don't have a line. I'm going to go get one made. And I'll be right back. But you go ahead and finish moving this earth. Because we got to get this thing done today.
It's probably going to fail eventually. It's got to.
So I'm putting an abnormal amount of torsion, or actually changing the physics of the way it operates, so one side is carrying and performing all the work.
Yeah.
Right?
Mm-hmm. But it's not designed to do that, so it's probably going to.
There's going to be failure. That, and I've reduced my lifting capacity, right?
Yeah, and then cut it in half.
So now we're understanding synchronization. The other thing is, say I'm using, remember this guided rail here? You see this? I got it's called Thompson rod, hardened rail that has a bearing it's riding on. Say I had 2 cylinders trying to move that, and I had one that could push faster and stronger than the other one. You reckon I run the risk of this going to get this jacked out of shape to where it's going to bind? You with me on that? Could you envision? See, this is where I'm trying to get that imagination going. Remember I was asking you to be able to look at things and envision how it works, sir? Yes, sir.
I've seen that happen with the skid.
So have I. It can happen real quick.
Oh, yeah.
Pneumatics, it happens quicker than hydraulics, believe it or not.
It's scary sometimes.
Oh, when they jump back, it can get ugly quick.
First time I saw it, I almost pissed my pants.
Well, I can relate to the feeling. It is just, it puts a big startle in you. I mean, when you think about the amount of weight that's being suspended or things going on, when a piece of equipment jumps back into shape after it's been distorted because something happened, it gets your attention in no uncertain terms. So we understand now about we have to be able to synchronize cylinders both in extend and retract, because we could realistically get something really jacked out of shape, and I guess it's the best way to say it that really relates to everybody, or it gets it so torsionally bound that it stops moving, but it's also doing something else. Those bearings aren't designed to deflect that much or to deflect that way, so now I've probably broke some bearings. All right. Now, let's scroll on down here, and we'll get this. And everybody knows that they had which is be closed here in about 35 minutes for the refund checks open this evening. Is everybody on the E2 campus? Does everybody know what E2 campus is?
I don't.
Home base.
Oh, that's what
Well, let me go ahead. I'm gonna bring it up because I went over this before, but it's basically depending whether we have, gentlemen, if you go down here under security, where was it at? Called safety and security.
That should be just security.
Pardon me?
Should be
It's
just
under our balcony
security.
bridge.
On the left.
Safety and security. And then from that page right there is E2 campus. All right? Sign up. I knew at lunchtime, actually before lunchtime, I think it was 11 o'clock, that those checks are going to be out there from 4 to 6 because of E2 campus. Actually, it's 11:56 that they put it out through email. Now, everybody relies on our website. Website takes a little longer to update. It's real quick to send you an email. To call to have our website updated takes a little bit longer, sometimes as much as an hour. Isn't that correct, Ed?
Mm-hmm.
When we have snow and they close the school or it's late opening, sir.
Or maintenance.
Or maintenance.
Yeah, they shut down the website a few times already.
Yeah, but the thing is, it takes longer to update the website than it does to send you an email. So E2 Campus is definitely a way to go here. All right? Now let's reel us back in. Now, the other thing that we're going to get introduced to as we progress through this, guys, is actually accumulation tanks. All right? It's not something you see a lot on hydraulics. They're definitely predominant when it comes to pneumatics. But you get into, but what they're trying to do instead of accumulation tanks is utilize regenerative circuits. So that way they're picking up the needed extra flow from the returning flow of fluid. All right? Instead of sending it all back to the tank, let me pull what I need from what's trying to return to the tank. Couldn't quite get the beat of it there.
Yeah.
All right. I don't know why they put a blank sheet in. You think that you You eliminate the blank sheet and go on with it. All right, exercise objectives. You're gonna learn how to control the direction, force, and speed of the cylinder, which at this point you should have a good understanding of, I would hope. Any questions in regard to those items of discussion? Everybody's just so intense. All right. You're going to be introduced to the operation of a directional valve. This is actually get into the looking at the inside workings of it. To describe the effect a change in the system pressure and flow rate has on the speed of a cylinder. To describe the effect of a change in the system pressure or flow on the force exerted by the cylinder. Discussion. This exercise introduces 3 types of cylinder control functions: directional control, force control, and pressure control. The direction of motion of a cylinder is controlled by selecting the direction of flow of oil through the cylinder using a directional valve, which you should, I would hope, have that fully understood. The force output of the cylinder is controlled by modifying the amount of pressure available to its piston using a pressure control valve. Jason, I know you and I went through that immensely in regard to the annular side of a cylinder versus the full side. All right, the extension and retraction speed of a cylinder is controlled by modifying the flow rate to the cylinder using a flow control valve. Now guys, the flow control valves and all these other valves that you're seeing them in a real manual form. I mean, truly manual form. Once we really get into the field, these things could actually be composed within a large manifold block. And when I tell you a manifold block, I mean a block that is essentially 3 to 4 feet wide, as much as 18 inches thick, and could stand 4 to 5 feet tall. And basically have stacks of valves that it may be electrically controlled on top, but the electrical controlled solenoid is actually controlling a larger hydraulically driven solenoid valve that is controlling larger volume of oil. So they actually tier this so that I use a much larger spool now, so I can, using the hydraulic pressure from the electrical circuit, to actually be the piloted oil to direct a spool which controls a much larger volume. What would that be similar to? Think of electrically.
Daisy chain.
Control relay. I'm taking small voltage to operate the coil in a control relay that closes contacts which can handle higher amperage. I use electrical control to move a small amount of oil, which is all I need for pilot oil. Pilot oil is only shifting a hydraulic valve back and forth. All right. So instead of an electrical circuit using an electric magnet and moving the spool, all right, I actually use hydraulic pressure. It's spring-centered, but I introduce pressure on this side to push the spool because it takes more force to be able to control that larger volume, right? I got a much larger valve, so it takes more force, so I can use that oil from that smaller electrically driven valve to move this piloted operated valve, which in turn moves oil that could possibly go through a 3 or 4 inch line. All right. Does this make sense, guys? Or is any?
Yeah.
All right. Now we're getting in, again, more simple. There you go. Automatic accumulator with bleed down. We're looking at different styles of accumulators. I'm not a big proponent of accumulators in hydraulics. I just tell you that right now. But there's various styles of accumulators, and they will discuss that in this chapter.
We don't have an accumulator, do we?
Yes. There is an accumulator. I think, if not on here, I know there's one over there. But when we get into the larger systems, my one hydraulic molding machine had 3 accumulators that were 12 to 14 inches in diameter and stood 10 feet tall.
So is this basically a reservoir?
Pressurized reservoir.
Air.
Yeah, some have gas, some use air, some use a spring-loaded bladder. There's various, that one's actually air, But there can be different gas, argon or nitrogen. Most are nitrogen.
It's similar to like a pressure tank in your house from a well.
But it's for hydraulics.
Yeah. It's got a bladder in here that separates the gas from the oil.
Okay.
All right?
What's the,
So you can repressurize it. Same thing that you have in your pressure tank at home, if you have a pressure tank at home. I don't know if this has.
So what would that actually, how would that benefit a circuit?
Pressure pump.
Pressure or flow, generally for pneumatics, it's flow. I don't have, or volume. I don't have enough volume of air to perform the function. But I can take that secondary or that piece of equipment, put a tank underneath of it, and when I need that volume of air, I pull it from the tank, because I don't need it all the time. There's only certain operations that need it. So I pull when I need it, and the rest of the time, it's getting replenished what it did use almost instantly. But there's not enough in the normal line to supply what's needed in an instant. Because, well, you think about it. Say I got a, let's use the hypothetical thing. Say I got a 3-inch bore cylinder, all right? And I'm trying to fill a 3-inch bore cylinder like this with a 3/8 inch airline. Do you think I got enough volume to fill that area inside that cylinder? Especially when I start getting towards the extend and I have to fill the complete body of the cylinder? You with me?
Yeah, but why wouldn't a 3/8 inch line fill that?
All right. When you go put air in your tire on your vehicle, does it say it's down to 10 pounds of pressure? Did you have your hand up, or you just?
No.
All right. Does the air pressure go up like that to 32, or does it take a while?
And the more pressure in the tire, the slower.
So why is that? Is it volume, or is it speed, or is pump not enough, or what?
I would say volume.
There you go. That's where your accumulator comes in. See, I can run a 3/8 line to a 5 or 15 gallon tank, accumulation tank. From the accumulation tank, I can run a 1/2 inch, 1 inch, 2 inch line to whatever it needs. That 3/8, if I took that straight 3/8 inch line, or say I was even able to run a 1/2 inch line over to the equipment, I still can't go to a manifold and supply 4 or 5 operations that need 3/8 inch airline filled. Something is going to fall short.
It's a booster.
It is a booster. That's another way of looking at it. I didn't think about saying it that way, but yeah, it's a booster.
So it boosts the system when needed.
Volume, volumetrically, not pressure, volumetrically. Remember, this is all about volume. I got sufficient pressure. I just, because I'm filling such a large cavity, my pressure's going to drop off if I don't have enough volume to take up the space.
So it equalizes.
Well, let's go, I'm going to try to do it this way. You go to fill up, say if your fish tank, you got a 10-gallon fish tank. You're using that 1/2 inch water hose. If I took a 5-gallon bucket and dumped it in there, it's almost instant that I fill up a 5-gallon tank. The 1/2 inch line takes a while to fill that same area. The 1/2 inch line can do it with greater pressure than if I dump the 5-gallon bucket in, right? Because it's under pressure. What I'm dumping, the gravity is only affecting pressure-wise, correct? But I'm dumping in a larger volume, taking up that area of volume.
Okay.
When we're engineering these things, these are some of the things we lose sight of, and that's where we start getting affected adversely. We sized everything we need for it to function, right? Got the right size cylinders, right size valves. How do we supply it? Right?
So you need a
good driving force.
And the volume behind that driving force. That's the reason when you see hydraulics, even the pump we have in those units, they're probably a 5 to 10 gallon pump. 5 to 10 gallon an hour pump. Or a gallon per minute, pardon me, pump. Well, when you get into larger hydraulic systems, you're going to see 5, 10, 15, 20, 60 gallon a minute pump. You're going to see variable volume. You're going to see various variable volume. You're going to see vane, you're going to see gear. There's different styles of pumps for different applications. You're going to see variable stroke for positive displacement pumps, and different ways that they do variable stroke. And then some even use pilot oil to change the rings in there, which also changes the stroke of the pump. And believe it or not, they'll have these pumps working off a crank, but by turning it sideways, increases the stroke length. But by bringing it concentric, where it's right in the middle of the stroke pattern, all right, I shorten the stroke. But as soon as I start offsetting, so instead of running parallel, so I'm running around the circumference, the shortest distance, I've only got a nominal flow at that point, right? Because I've really got a short stroke. Now imagine I start elongating it, because instead of being perpendicular to the body, I turn it like this. Now I start increasing the stroke, because now where it can pump out to, that piston can actually move out further. So I start increasing the volume of oil that can be produced from that pump. A lot of those are utilized, and they have, again, fixed volume pumps. But then what you'll see in the systems will be actually multi-stage pumps. In other words, I may bring in 3 pumps to do one function, but only have one to control pilot oil. Because the pilot oil line is only 3/8 of an inch in diameter. Doesn't need a large volume, just needs a constant pressure. But when I say I got large traverse cylinders are moving a large mass of equipment back and forth to get it to a point that it can perform work. All right?